Hello, A-level chemistry students. Right now I'm going to explain about the still chapter organic nitrogen compounds. It is specific to 27.5 amides. Let's see the structure and the property of amides. Property of amides. Amides have the functional group of R, C double bond O and H and then R. In here, R complement and also R refers to alkyl, aryl or hydrogen atom. Amides are extensively hydrogen bonded, having both hydrogen dipole positive atom on nitrogen and lone pair of electron on the oxygen and nitrogen. Most amides are solids at room temperature and pressure, and quite a number are soluble in water. Why is amide solid at room temperature and pressure? Because it has quite high melting and boiling point. Of course, if high, it doesn't mean that it is more than 100 degrees Celsius. Unlike amines and amides, form neutral solutions in water and can be protonated only by strong acid. If by strong acid, it means that amide has property of an alkali. The site of protonation is unusual and explains why amides are such weak bases. Let's see how the weak bases of this one of an amide. The lone pair on the nitrogen atom, this one, the nitrogen atom contains a lone pair on the nitrogen atoms in amides is in p orbital and can overlap with the pi orbital of the adjacent carbonyl group. This is the carbonyl group C double bond O R. The electrons are attracted to the electronegative oxygen atom. So the electrons attracted to the electronegative oxygen atom. That makes this one, the C of the electron, is being taken by the oxygen. It is called as electronegative pull. And then this one, the lone pair of the nitrogen, this one goes inside. Why is it goes inside? We know that nitrogen is an electronegative element also. So the electron of the carbon should have pulled by the nitrogen, but the electron of the nitrogen is pulled towards the carbon and then carbon towards the oxygen. Why is it like this? Because the lone pair of the nitrogen overlap with the pi orbital of the adjacent carbonyl group. That makes the electron are attracted. Okay, so the electron here are attracted to the oxygen atom. It is not the electron is being taken, but the electron is attracted. This confers the considerable double bond characteristic to the CN bond. So this confers considerable double bond characteristic to the CN bond. Now, does it mean it has a double bond? No, it has a double bond character. And then CN, including restricted rotation about it. Compared with alkenes, alkenes is different. This has great significance for the stoichiometry, stereochemistry of polypeptide chain in proteins, which we shall meet later in topic 28 about the nitrogen compound again. Polypeptide contains secondary amide group. Okay, let's see how is it secondary amide group. Because here the nitrogen is bonded to the carbon and carbon. We know that if an active site of a molecule bonded to different groups of atoms, it is considered to be a secondary structure. Okay, let's see this one. It has restricted rotation about it. We know that the CN bond, there's an H, this N bonded with the C again. Okay, it has this one the electron goes inside, that makes the double bond character. It has positive. This one the electron is being pulled, that makes become negative. And then this one, it has only the character. And then the NH, the amide, when it bonded with another amide, the N will lose one hydrogen, and then the electron make bond with the other carbon of the amide. The properties of synthetic polyamides such as nylon covered in section 28.2 in polymers. When amides react with strong acid, it is the oxygen atom rather than the nitrogen atom that is protonated. Okay, it means protonated. It means it has proton. So whenever there is acid, when amides react with strong acid, so this one, we know that amides, this is structure of amides. It reacts with acid. It becomes like this. This is incorrect. This never occurs. Okay, so the electron between the carbon and oxygen gives to the hydrogen ion. That makes the structure become R, C, OH and H2. The C become dipole positive. Protonation of the nitrogen atom would result in a positive charged nitrogen adjacent to the carbon dipole positive of the carbonyl group, an unfavorable situation. On the other hand, the protonation of the oxygen atom allows the positive charge on the cation to be delocalized over 3 atoms, an energetically favorable situation. So it becomes like this. This is why the reaction can occur at the same time, either this one, or this one. Okay, so the protonation, this one is in the positive carbon, can be in the nitrogen atom, can be on the hydroxide. So although amides are more basic than other carbonyl compounds, because why amides are more basic? Because of the electron donation from nitrogen, they are still much less basic than conventional nitrogen bases such as amines. Last time we studied already about amines. Because amines has a specific structure, especially about the positive inductive effect. So if in the amines, the positive inductive effect support the electron to the nitrogen, that makes the nitrogen able to make a additive covalent bond with the hydrogen ion. In this one, in amides is different. The electron here, the electron of the carbon is donated to the hydrogen ion. And there is another electron withdrawing group which is called nitrogen. but nitrogen attracted, the electron of the nitrogen is attracted to the oxygen. Now let's see the preparation and hydrolysis of amides. Amides are most readily prepared by reacting acyl chlorides with ammonia or amines. Okay, so the starting point here is acyl chlorides. R C double bond O Cl or X. X represents the halogen. The halogen is chlorine, Cl. So in here, when we know that acyl chloride react with amines, this is methylamine. It will become an amide plus acid. Okay, let's see the reaction. So you had made already the mind map for the reactions in AS level. Now you need to continue the from acyl chloride. We know that carboxylic acid can become acyl chloride by reacting with PCl5, and then the acyl chloride continue become amides. Reaction with amines. So HCl formed react with an excess amines to produce salt. When we discuss about the subchapter amines, we already know that HCl reacts with amines to form salt. Okay, reactions of amides. Reactions of amides with water. Because of the high degree of positive charge on the carbon atom in protonated amides, they are susceptible to nucleophilic attack. Hydrolysis is usually carried out in a dilute sulfuric acid. It is quite slow reaction. However, heating under reflux for several hours is usually required. So in here, the condition is reflux. When amide react with water, it needs a catalyst. The catalyst is an acid. So it is aqueous acid, and then the amides will become carboxylic acid. So this is the reaction refers back to carboxylic acid. Okay, and for plus NH4 ion. And then next, amides can also be hydrolyzed under basic condition heating with sodium hydroxide aqueous. We note that if it is hydrolyzed, it means cutting. This so there are two different reagent how to hydrolyze. Hydrolyze an amide, it means reaction of amides with water. With acid will produce carboxylic acid and salt. Amides with sodium hydroxide aqueous will produce salt of carboxylic acid plus amines. This is similar to the reactions of ester hydrolysis. Ester hydrolysis, when react with dilute acid, it will become carboxylic acid and alcohol. When ester hydrolyzes in the presence of aqueous alkali, then salt of carboxylic acid and alcohol is formed. Now let's see the mechanism of the hydrolysis. Okay, the mechanism is similar to the hydrolysis of ester, as I told, is similar to the hydrolysis of an ester. So in here, the carbon double bond with oxygen, the oxygen has a lone pair. The lone pair donated to the hydrogen ion. That makes the hydrogen ion attached to the oxygen, and then the electron of the carbon is taken by the oxygen to make itself stable. Okay, and then at the same time, the oxygen of the water has a lone pair. The lone pair donated to the carbon of the amides, and then makes a bond. So there is a temporary bond, and then the electron of the hydrogen, one of the electron of the hydrogen is being taken by the oxygen. That makes the hydrogen is, one of the hydrogen is lost. And then the nitrogen, the lone pair of the nitrogen, make a active covalent bond with the hydrogen ion. Okay, so there is a NH3 positive. In order to make the structure to be stable, so the electron, the lone pair of electron of the oxygen taken by the carbon, attracted to the carbon, and then the electron of the carbon is taken by the nitrogen. Okay, that makes the NH3 is gone from the structure of the amides, and then there is a lone pair. There is a lone pair of the nitrogen in the structure of ammonia that make the active covalent bond with the hydrogen in the amide, in the temporary or intermediate amide structure. This hydrogen make the active covalent bond by the ammonia. Then the electron of the hydrogen is taken by the oxygen to make itself stable, and then that makes the NH4 positive is formed, and then the carboxylic acid is reformed. So these are the intermediate reactions of the hydrolysis of an amide. Okay, amides are intermediates of the hydrolysis of nitriles to carboxylic acid. This is a nitrile. This is HCN, cyanide. Plus aqueous acid, it will become an amide. And then amide hydrolysis, heat with aqueous acid will become carboxylic acid and salt. So if we have a nitrile react with aqueous acid, nitrile reacts with aqueous acid will become amide. Amide continue with aqueous acid will become carboxylic acid. So how do we make nitrile become carboxylic acid? The nitrile must be converted into amide, and then amide goes to carboxylic acid. We know amide is an oxidation product. So if it is oxidation, then it means amide can be reduced. So amides are reduced into amines. Amides can be reduced to amines by lithium tetrahydroaluminate. Okay, so amide in lithium tetrahydroaluminate in dry ether will become an amine. Next, so please remember the hydrolysis and oxidation and reduction of an amines. Okay, now let's see the amino acids. Amino acids have two functional groups. It is the functional group the two amino acids, alpha amino acid, form an interesting class of compound apart from their great importance as the building blocks of protein. In many compounds containing two or more functional groups, the reaction of one group can be considered independently of those of the other group. They are often widely separated and dissimilar to each other. In two amino acids, however, the two groups are near to each other. What is more, they are opposite chemical types. The NH2 group, which is basic, and there is an carboxylic acid, which is an acidic. Interaction between the two is inevitable. Physical and chemical properties. We are going to continue the chemical and physical properties of amino acid in the next session. So until right now, we know there are two different two different functional group in amino acid, which is an amine and also carboxylic acid.